Hi everyone, in this video we're going to look at how we can solve this equation over here. Log base 9, 4 plus log base 3 x plus 4 equals to 2 log base 3x. How we're going to do this, right, is again the same old trick. We're going to use the property that log base an equals to log base an implies that m is equals to n. So now let's see. So on the two sides of the equation, the right side is almost ready, but the left hand side is not. So let's see what we can do to it to make it ready. So log base 9 4 plus log base 3 x plus 4 is equals to 2 log base 3x. Okay, so let's recall some tricks that we want to apply. We want to use this eventually. But first of all, right, we must make sure that the left hand side of the equation must be a single log. But the problem is now, right, I have two logs that have different bases. Because here I have log base 9. I have log base 9, whereas for the second log I have log base 3. And on the other side, if you pick, it's actually log base 3 also. So we have to change the base so that they are having the same base for all logarithms before we can apply any law. So here, right, the choice is between whether we choose base 3 or base 9. But because on the right we have base 3, right, so I think it makes sense to change this to base 3 also. So now let's change the first log to base 3. So in this case, let me just write down the change of base law first. Let's use rate. Okay, recall that we have our change of base. So if we have our log AB, right, we want to change to log base C. We can actually just write as log base C B over log base C, the original base, which is A. So in this case, we want to change to log base 3, so here will be log base 3 4 over log base 3 9. Okay, the rest of the things are still as it is. Let's just copy them down. Okay, what is log base 3 4? We don't know. It's going to be an irrational number, but log base 3 9 I know. Log base 3 9 is actually 2. Okay, plus log base 3 x plus 4 equals to 2 log base 3x. So on the left, right, both are having the same base already. But the problem is we still cannot combine because of this over 2 over here. So let's just rewrite this over 2 as half. So half log base 3 4 plus log base 3 x plus 4 equals to 2 log base 3x. What's the point of writing this half? Okay, after we write this as half, right, we can actually make use of the power law because this half, right, can be brought up to the power of 4, meaning that our log base 3 4 to the power of 1, sorry, not 1/3, log base 3 half, log base 3 4 to the power of half. Okay, what am I doing? Okay, sorry. So here I will have log base 3 4 to the power of half plus log base 3x plus 4. So are we on the right track? Let's see. Now, right, we don't have the half in front already. So now we have just log base 3 4 to the power of half plus log base 3x plus 4. And now, because they have the same base, we can apply the product law from here. So now we are on the right track. We are on the right track. This will give us 4 to the power of half is square root 4. Okay, 4 to the power of half is square root 4. This is the indices law. And square root 4 is 2. So this will be 2 log base 3 2 plus log base 3x plus 4 equals to 2 log base 3x. And now we are ready finally to put this as 2 log base 3 2 times x plus 4. So on our left, right, we actually are almost ready to apply the property, but on our right we still have this 2 over here which we cannot apply because we want a very clean log. There's nothing in front of log. So log base a, so we don't want this 2. So again we're going to use the power law again to move it up. So this will be log base 3x squared. So now we are ready, we are in position. So using that property, we know that 2 bracket x plus 4 is equal to x squared. So 2x plus 8 is equal to x squared. X squared minus 2x minus 8 is equals to 0. So from here, right, we just have to solve the quadratic equation as before and then substitute to our original equation to check. Okay, the remaining steps are the same.